Okay, so this is a section 2. Obviously, you have 6 subsystems. Essentially, you want to say what it is it does, any timings, power supplies, what does it interface with. Parts lists are not specs. Okay, so if it's something like a latch, you might want to say that it should be able to remember one bit of information. You could say that it has a 5-volt power supply. There wouldn't be any timings. You could say that it should interface with a 7/4 series counter, for example, something along those lines. Do not say it has an AND gate, it has an OR gate. They are parts lists. Okay? As long as you stick with about 3 specs, maybe 4 specs, you're absolutely fine. Alternative subsystems considered. Now, we have a folder for that, all of Dan's circuits. We have put it on Teams for you in a nice place that's easy to find. So I'll click that most circuits needed. So you can see here, there's the latch. So if you're looking for an alternative to the latch, notice this latch has doesn't have the proper input button. Yeah, so you need a proper input switch. Okay, but an alternative to a latch would be the SR flip-flop, and I'm pretty sure if you did scroll down, you will find that we will have, there we go, there's the SR flip-flop. How do I get that in? I would always use snipping tool like so. I'll just move over to this page. So new, literally drag what you want there, and it should open up there. I always go Control C to copy, and then we'll pop it into here. Okay. If it looks a bit odd, you can make it a bit smaller. The other thing you can do, just so you know, guys, when you've got this, you can right click and you can go to text wrap. I tend to use square, but you can use in line with text or tight. I tend to use square and then just do that. And then you've got the option of moving it, shifting it about. Yeah. Okay, so there's your alternative. And then what you'll do is you'll write why you've used it. So it might be I've used the OR gate latch because I've got logic gates which I'm using, so I can use the same chips. Or you could say that I want to press for a logic 1. Notice the SR flip-flop would be pressed for a logic 0. Okay, so that's the idea of what we mean by your alternatives. Then for your one, make sure that you don't have wires going off the page. Obviously, delete this. Make sure it's non-blurry, so you can delete all of that. This is just an op-amp amplifier I've just got as an example. Notice you haven't got wires going off the page. You've got text boxes, yeah, so you've inserted. If you want to add a text box, it's dead easy. Insert, where are we? Text box, always just use draw text box. There you go. There's a text box there. Yeah. And you can obviously shift that around and put it wherever you want. Okay. So you can add that. Let me just show you how you would take a subsystem off. So here's a circuit which a student has built. So this one is like an up-down counter using it's got a sensor in there. Notice this circuit would not get all the marks because you haven't got switches and resistors. And you also haven't labeled the transistor. Yeah, the transistor we use is the ZTX450. Please ask us if you're unsure on what ones to use. But anyway, so let's assume I want to test this bit here. So I'm going to take that, Control C. I'm going to stick it over here. Notice I don't want that bit there. So I want it as a standalone system. You could just take that off there. But you know what? Because I'm testing it, I'm actually going to stick an LED on the end, just for testing purposes. There, I'm going to put a resistor on as well, down there. Remember, resistor wants to be less than 1K. Let's go 220 ohms would do. And then stick it down there. Okay, so I can now test that. And I can put that in. So that's a standalone subsystem, and it's also ready to be tested. You might want to also put a voltmeter on there, but I can do that later. So I'm going to copy that. I'm going to put that back. Oh, sorry. I'm going to put that back into my section 2. So it's not really a latch now, is it? I'm just showing you other things. So this is just to test this. So let's get rid of that one. Let's put this one in. Get rid of that. Get rid of that. There you go. Again, if you want to make that square, you can text wrap, go square. You can shift it about them. Okay, so there's my circuit diagram of my chosen subsystem. Calculations. So for this particular one, there won't be many calculations you can do, but you might want to just discuss it. You might want to say, as the light level drops, the resistance increases, or say it the other way around, as the light level increases, the resistance decreases. This should switch the NOT gate when it goes past the trigger voltage of the NOT gate. If you want to find out what the trigger voltage is, you can literally just type in 7414 data sheet or trigger voltages into Google. You can actually add that in. That'd be quite nice. If you want to put a calculation here, you could, because obviously you got 5 volts across these two components. The LEDs use 2 volts, so it's your classic 3 volts across here. The LEDs use 20 milliamps. If you're unsure what the LED uses, again, just go into Google. What is the current and voltage of a typical LED? Yeah. So you've got to sort of show these ideas. So you can put some explanation about how it works, talking about the light level dropping or increasing, then it's switching when it goes past the threshold. Okay, this is just an example. Again, this is just the op-amp example again. So you'll notice there's some actual equations for this one. So if you're testing things like op-amps, transistors, timing circuits like astables and monostables, you will find there will be equations that you can actually use. So you can actually just stick the equation in. Where would I find the equations, you might ask yourself? Well, I've actually created, where are we, a annotated data sheet, which again is also on Teams. So Nick's kindly put all of this on Teams, just in the general tab, and it's all annotated. So if I'm using a transistor, there you go, collector current, base current, gain, it's there. If I'm using an op-amp, you've got equations there. If you're using things like filters for audio, you've got filters there. If you're using breakpoint frequency there as well. If you're using time constants, monostables, astables, it's all there. And to be honest, you can even, if you really wanted to, if you're using this equation, just do that. Snip it out, Control C, and put it back into here. If you're testing like an astable, for example, yeah, and then you can just put your values in. Okay. Test procedures, write down how you're going to test it. So if I am testing this one here, what I would do is I would say that I would change the light level by sliding the slider, and then I would observe when the voltage at which it switches, which the LED turns on. Yeah, that's what I would be saying. Or the LED turns off. It might be you want the LED to turn off. You might want a logic 0 rather than a logic 1, depending on your application. Okay, that's how I would be testing that. So I would write that in words there. Don't use AI, it's crap. Yeah, it doesn't work very well. So please just write down in words how you're going to test it. Testing results, again, you can use real testing or you can use simulations. So what I would do, here we go, here's my testing of this particular bit. I would be tempted to put a voltmeter on there. Let's stick a voltmeter on there. So a voltmeter across there so you can tell when it's going to switch. Move that out a bit. So we've got the voltmeter there. So you should be able to see the switching voltages. Okay, so you can see it's quite, maybe we might need to change that resistor value, but you can kind of see the idea of when I decrease the light level on here, decrease the light level there, it's changing it, and then you can see the LED is switched there. I've got about 600 millivolts at that switching voltage. You might want to change that, to be honest, but you don't have to. you can just have that as your results. It doesn't matter. There you go. It's a bit more. You see, it's a bit easier to see where it switches there. Yeah, so about 700, 800 millivolts. You can see that turns on. Yeah, so the NOT gate now becomes a logic 1 at the input. So logic 0 at the input and a logic 1 at the output. Let's turn the LED on. That would be absolutely fine. Yeah, for your testing purposes. Yeah, so at about 700 lux. And when you do it in reality, we've got your phone's got a light meter. You can actually check it if you want, but you can see that would be absolutely fine. Yeah. So going back to this one, what you might want to do, you could, if you want, insert a little table, and you could say something like light level, voltage, LED, state. Yeah. Do a screen grab of it working, and you could say the light level is blah, 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 blah. The voltage was blah, blah, blah. The LED is off. The light level is blah, blah, blah. The voltage is this, LED on. It's very, very easy. That would be absolutely great. That would show it really well. Analysis and results of in comparison with initial spec. You would literally go up here, copy your 3 or 4 spec points, and then just justify whether it does it, whether it meets those spec points. Yeah. So your spec points for this particular one may have been that the LED should switch when the light level goes below 1,000 lux. You might say that it should be powered from 5-volt power supply, and you could say that it should interface with a latch, for example. Obviously, the interface with a latch bit you would have to sort of check later on, but you could still say, because it turns the LED on, that will provide enough current to latch or unlatch as well, because you've got at least 20 milliamps of current available. So you could say something like that. So you've got to do that times 6. Now, if you're quick, I think you can do one in an hour quite quickly, testing on there. Okay, so give that a try and see what you can do. Okay,